Good morning and welcome to today's seminar. My name is Sonia Collier. I'm a staff member of the Climate Change Mitigation and Emissions Research section in the Research Division. I'm also the contract manager for the study titled Collection of Tractor-Trailer Activity Data, and it gives me great pleasure to host this closing seminar. So first, I would like to point out to the folks sitting in the room that if there is an emergency, please, you're going to have to exit the room and calmly go to Cesar Chavez Park, which is southwest of this building. Please take note of all the exits. And I'd like to thank you all in advance for joining us today. So the title of today's talk is Real-World Activity of Heavy-Duty Tractor Trailers Hauling Container Chassis, Flatbed Trailer, and Tank Trailer. And it will be presented by Dr. Thomas Durbin, who is an adjunct professor at the University of California, Riverside and a research engineer at the College of Engineering Center for Environmental Research and Technology, or CE-CERT, as we like to call it. So he has extensive experience in emissions measurement of on-road and off-road vehicles and has worked extensively with CARB on a range of topics related to real-world emissions of vehicles, emissions controls, and real-world activity data of heavy-duty vehicles. So his full bio is available on the website for this seminar, which I'll show you at the end of this introduction. And also, there's going to be some updated slides posted to the seminar page after this presentation as well. So with that, I'm going to begin the introduction. So California has set some ambitious goals to reduce greenhouse gas emissions significantly by 2050. And of course, this is to reduce the worst effects of climate change. And we're going to accomplish this using various strategies to decarbonize our economy and also increase efficiencies where possible. If we take a look at our greenhouse gas emission inventory, we see that a really large contributor to greenhouse gas emissions is the transportation sector. And if we look at the piece of the pie for transportation sector, we see that the lion's share goes to on-road vehicles. That part, the on-road vehicles, can be broken down further into various categories. And you can see that heavy-duty vehicles make up a very large share of that as well. And that's the sector that we're really going to be focusing on today. So one of the strategies to reduce greenhouse gases comes in the form of the Phase 1 and Phase 2 greenhouse gas regulation. This mandates improvements in heavy-duty truck greenhouse gas emissions using multiple strategies and sectors within that group of vehicles. So for instance, the rule mandates certification for engines themselves, as well as tractors such as Class 7 and Class 8 tractors, vocational vehicles, and pickups and vans. And additionally, some mandates or certification is required for the trailers that are hauled on the road by tractors. So the tractor-trailer greenhouse gas regulation was adopted in December 2008, and it requires that long-haul tractors and trailers implement aerodynamic devices or improvements. It also requires low rolling resistance tires, and pretty much now all trailers of a certain type are required to have these improvements. So these aerodynamic devices are required for box-type trailers at least 53 foot in length. And these can include side skirts and trailer tails, anything that improves the aerodynamics of the trailers. So this practice is actually well accepted in industry, and the use of trailer aerodynamic technologies is actually pretty widely used at this point, and pretty much 80% of new trailer purchases include these. And this continues to grow. And additionally, fleets have reported significant fuel savings, so it's economically advantageous to implement these aerodynamic devices. So the Phase 2 standards will result in trailers being certified with these technologies, and the tractor-trailer greenhouse gas rule already requires this for long box-type trailers. But there are other trailer types on the road, and you've probably commonly seen them. For instance, there are tanker trailers, curtain side, flatbed, and container chassis. So we don't really have the data up until now to determine what speeds these types of trailers typically operate at, or what distances they travel at. And these two factors really determine whether aerodynamic devices will be effective at reducing greenhouse gas emissions. So with that kind of data, we could determine whether it makes sense to regulate these types of trailers further. So the objective of this study is to collect tractor-trailer activity data that will also be used by our staff here at CARB to assess the potential of greenhouse gas emission reductions from improved aerodynamics for these 4 types of trailers that are not yet regulated. The main method for doing this is that tractors hauling these types of trailers were instrumented with data loggers to collect engine control unit data and GPS data. And a side benefit of doing the study is that all 170 parameters were collected. So we have a rich data set of activity data to investigate other aspects of their operation. So for more information, you can take a look at some of these websites. First of all, we have my section's website, and a new website will be coming soon for more updated information. There's also a seminar link and a project link for this specific project. And if you want to know more about the regulations, we have several heavy-duty vehicle rulemaking portals available. So there's work groups, there's the low NOx, there's the Phase 2 greenhouse gas rule portal, and opacity and heavy-duty INM. So with that, I'd like to welcome Tom up to give us more information about his study and present his results.
Okay, thank you, Sonia. So I want to start off by acknowledging my co-authors, which include some of the folks that work with me at UC Riverside, as well as Andrew Burnett. He helped us do some of the data logging up north, and then there's also a number of ARB staff that worked in developing and kind of working with us on the data analysis and other things. So Sonia went in a decent amount of detail on the background of the greenhouse gas regulation. I don't necessarily want to repeat that, but I do want to emphasize that for this particular study, we are focusing on container chassis, flatbed, tanker, and curtain sides. And just one other thing, you know, when you think of these improvements, you can get anywhere from 1 to 10%, depending on how many or what type of devices you get. Many of them are in the 4 to 6% range, and when you couple them, you can get up to 10% benefit. So, so it's something that, you know, with a lot of fuel costs, it's certainly worth investigating. You know, both from a regulatory standpoint, but also from an economic standpoint here. So in terms of the activity portion, which was the main portion of the study, we focused on container chassis, flatbed, and tankers. We didn't do curtain sides, and I'll get to that in just a few slides here. And so if you look at kind of evaluating the potential for greenhouse gas benefits from aerodynamic technologies, there's a couple of important things. You want to figure out how many miles the truck is traveling. And secondly, you kind of want to understand the speed bends, or what fractions of the VMT are at different speeds here. And the figure there just kind of shows that the blue and the green lines in particular show the aerodynamic drag. And as you can see, as the speeds exceed roughly 45 miles per hour, that curve starts to go up fairly quickly, which indicates that that's a region where you potentially can get some of these greenhouse gas benefits. And so that's kind of one of the breakpoints we wanted to look at in terms of the activity data here. So the scope of the study was a little bit broader than just collecting activity data. We also looked at and evaluated a trailer database, a registration database from IHS or Polk, is what it used to be. And we looked at the 4 categories in terms of looking at that registration database. And then also we did a fleet survey for different fleets that owned some of the trailers of interest, try to get an idea of what type of operations they have, what type of loads they carry, you know, how often they're using the trailers, and what type of typical mileages there are. And then finally, the main part is the activity collection that we did. So here, this is the registration database. So we got a U.S. registration database from IHS or Polk, and it had about 250,000 records total of trailers, and it was again, it was focused on the trailers that are the ones of interest here. So it only included the flatbeds, the container chassis, the tanker trucks, and the curtain sides here. So the left portion of the graph shows the total number of trailers and how that breaks down in terms of the number of trailers in each of these categories. And you can see that the flatbed trailers are a little bit more prominent in the registration database, but there's also a decent amount of container chassis as well as tanker trucks here. And just so you can follow the abbreviations, the C/CH stands for container chassis. Tankers at the right are the tanker trucks, and then in the middle is the curtain sides, and then on the left is the flatbeds. And there's a couple of different sizes in terms of the registrations, 48 and 53 foot for the different types of trailers. So on the right, we had about 11,000 plus trailers that were registered in California. And here we again saw a pretty good fraction of tanker trucks and flatbeds, but the predominant registration was more so in the container chassis. So a little bit different between the California and the U.S. registration database. And here you can just kind of see the fractions of the database as it breaks down. Again, the U.S. is on the left-hand side of the graph, and the California distribution is on the right-hand side of the graph. And you can see a pretty large percentage of container chassis in California, but also a decent chunk of flatbeds and tanker trucks. Not very many curtain sides in California, and that we also weren't finding a lot of fleets that had the container chassis either. So that kind of pushed us to focus more on the tanker trucks, the container chassis, and the flatbeds in terms of doing the activity part of the study. And I don't necessarily want to suggest that this is a completely comprehensive database of trailers. You know, if we looked at, sometimes we did surveys of fleets that had trailers that were from the database, and they didn't always completely match, and also, you know, the year of coverage didn't go, you know, back before 2000. So, but we do think that it gave us a good segment of fleets that we could go out and contact and try to get more information through fleet surveys and or activity measurements. So one of the main things we did was we went and we sent out trailer surveys to the fleets that were in the Polk or the IHS database, and coupled that with phone calls in terms of, you know, some fleets that we were able to identify that may not have been in that database or ones that we were familiar with. So most of the survey was conducted through the database, but we also looked at a few other things. So what were we looking for out of this fleet survey? We were looking for information about how many trailers they had, how many tractors they had, what was their typical VMT, what was the load type, and a variety of different pieces of information. I'm not going to cover all that information in this particular seminar today, but as the report becomes available online, you'll be able to find a lot more detailed information about that in terms of the full report. So out of the 6,000 plus surveys, we got about 59 responses. So, you know, not a significant number, but still a pretty good body of information that we can use to better understand the, you know, the sort of the fleets that carry these type of trailers. Of those 59, some, about 8 did not have the trailers that we were interested in. So we're focusing here on basically those fleets that had the trailers of interest for us. So here's just a kind of a couple of pictures showing the demographics of the fleets that were in the survey. On the right-hand side is the number of fleets and how it breaks down. The darker lines represent fleets that were national or either from California or elsewhere within the country, and then the lighter colored bars indicate those fleets that were just California centric, and so that represented about 31 of the 51 fleets that we looked at. On the left-hand side of the graph, this just gives you an idea of the rough sizes of the fleets in terms of the maximum number of trailers that were found in each of these categories. So some very large fleets, but some small fleets were included in this survey. Okay, so VMT was one of the important things that we wanted to get a better understanding of here. And so this particular graph shows 3 different representations of VMT. On the far left is annual mileage for tractors, and that's for all the fleets that were that participated U.S.-wide. So that's the full 51 fleets. Then the middle graph shows a slight modification of that in that we're looking at the annual mileage of the trailer itself as opposed to the tractor or the truck. So again, there's some slight differences there that you might see, and again, that's more the U.S. Full U.S. survey that was conducted. And then on the right side is the California fleets that responded to this question. And what you can kind of see looking at all of them is that a majority of the fleets had trailers that were used more than 25,000 miles per year. And in California, many of those fleets actually had mileages that were above 50,000 as well. Okay, so one other thing I wanted to present on the fleet survey results was just, we did ask which fleets were using already aerodynamic devices. And here we've got a little bit of shift in the shading in that the light color is the full U.S. results and the shaded color is the California results. But what we did find was that many of the California fleets, in particular in California, were already using at least some kind of fuel savings device or strategy or fuel savings program in their regular operation already. So about 81% of those fleets that we had in the survey. And you can see there's a range of different things that they might be using, anywhere from speed limiters to either low resistance or tire monitoring. Some had SmartWay tractors, some were already using aerodynamic devices, different driver rewards programs, and a variety of other things. Okay, so this is kind of the main part of the presentation. This actually talks about the activity data that we collected here. We collected data from about 153 tractor-trailer combinations. So we actually put the data logging devices on the tractor or the truck, but in most cases, either the tractors were dedicated to a particular trailer, they only carried a particular type of trailer, or they would have records that were sufficiently detailed that we could distinguish what trailers they might be having in terms of the different types. So the data loggers, they included both GPS as well as ECM information, so we were able to collect both. The frequency of that data collection was 1 hertz, and we had about 170 engine parameters that we collected as part of that study. And you can kind of see on the right, this shows you sort of pictorially what the data loggers look like. And if you can see that, that figure there, it basically goes just below the dashboard. And, you know, generally we're able to package them so that it's not, you know, it's not too obtrusive to the driver as they're doing their regular routine. We also collected different information about the vehicle itself and the engine in terms of makes and model years, and a range of different things that might not actually be on the data logger itself. Okay, so this shows a breakdown of the fleets. We had 8 fleets total as part of our data set, split between the different types of categories, including the container chassis, flatbed, and tanker trucks. And again, the curtain sides had a very low population, so we didn't do much with that particular type of fleet. So that is not included in the sample size. So again, we had sort of a range of different fleets in terms of the size. We had some fleets that were fairly large with, you know, 60 plus trailers, and then some that were fairly small in that the number of trailers in the type range that we were looking at was only 4. So if you look at the code name in the center of the table here, the code is broken down that CC represents container chassis, FB represents flatbed, and TK represents tanker. And then the middle designation there, NC, represents Northern California, SC represents Southern California, and then CV represents Central Valley. So we did make an effort to try to get fleets that were in each of the different regions of California, and we tried to the extent possible, get differences in terms of their primary service duties. So we got some goods movement, some refuse trailers, some in agriculture, some in construction, and then some in petroleum. So a reasonable amount of diversity in the fleets that we were able to data log. So this just pictorially shows some of the type of vehicles that we were looking at and some of the type of applications that we had. On the left is a couple of the container chassis fleets that we data logged. In the middle is some of the flatbed fleets that we looked at, and then on the right is just some pictures of some of the tanker trucks. So once you have the information from the activity loggers, we basically took those back and processed them, and part of that was identifying the trips that were taken by the different trucks, and we did eliminate typically from the data sets first and last miles, just to maintain the confidentiality of the particular fleets that we were working with and kind of where they were working out of. So this just shows how we broke down the trips. Typically there would be a key on event, didn't necessarily coincide immediately with an engine on event, but the trips themselves were broken out based on the engine on and off. We had criteria for the RPM to ensure that, that we were seeing engine speed before we called it a trip. And then one important other element was, a lot of the trips, in some cases they were idle trips, is what we're calling them, where the speeds were very low. Maybe they're queuing at the port or at a location where they're either picking up or dropping off material. So very low speed trips, very low distance trips. We basically separated those out from our analysis. And the idle trips, in terms of total number of trips, actually represented a pretty decent chunk of the information we collected in terms of the trip numbers, anywhere from 25 to 75%. Of course, VMT is very low for those trips, so they didn't represent generally a big chunk of the VMT itself. Okay, so this is a sort of a heat intensity plot here, or table, and not expecting everyone to read all of those numbers and comprehend them quickly. But what you can see here in terms of the colors, the red is the most intense or the highest frequency part of the operation. The yellow represents the next level of frequency, so just slightly less frequencies than the red, and then the green represents operation that's where there was very little frequency. So in terms of interpreting this graph across the top, you will see the various speed bands. Each of those represent 5 mile per hour increments, and the speed that is represented on the chart represents the highest speed in that speed distribution. So for example, the first box represents 0 to 5 miles per hour. The last box represents speeds anywhere from 85 to 90 miles per hour. So not a lot of red or yellow above 70 miles per hour, so that's probably a good thing. And then on the left-hand side is basically the hour of the day that the activity was occurring. So you can see here that the greatest percentage of operation, and again we're looking at non-idle trips here, occurred more in that 55 to 65 mile per hour range. And in terms of the days, it typically was in the morning, afternoon time, as you might expect. And if you break that down, we have had about 72 vehicles, over 400,000 miles. We actually had each vehicle data logged for about a month or more. And if you project the mileage, about 35,000 miles. And the key thing at the bottom is just that the speed is greater than 45 miles per hour for about 65% of the VMT. So flatbed trailers, again, same basic heat map type of table here. And here again we had a pretty decent chunk of trucks. Here we had a higher total VMT, annual VMT, typically for the trucks that that we data logged here. And you can see with that higher VMT, we also had a greater fraction of the mileage above 45 miles per hour. And we'll look at some of these fleets in a little more detail here in just a few more slides here. So the tanker trucks, we had a smaller distribution of tanker trucks. And again, you still see in terms of the VMT percentage as a function of speed, that a lot of the speed was occurring sort of in this higher or above 45 mile per hour zone. And here almost 90+% of the speed is occurring in that zone here. So, okay, let's just kind of look at some of the specific fleets, and you can kind of see how they differ in operation, but how in many cases there were some similarities in terms of the amount of VMT that was accruing above 45 miles per hour. So the first fleet here, kind of, if you look at the heat map here, that indicates where the origins of the trips were. And you can see this fleet was kind of ran between the Bay Area and the ports there to sort of, the Sacramento or locations in Nevada. And so it kind of had a split distribution. Some of the trips were fairly short in that they were trips that were taken in and around the port area. Some of the trips were longer in that they were hauling the product from the port to a longer destination. And here we found about 75% of the trips were non-idle. About 91% of the VMT was above 45 miles per hour. So second fleet, a little bit different. We're going down to Southern California. So the map there shows basically the Los Angeles area. A majority of those trips are in the San Pedro, Los Angeles, and Long Beach port area. And so this was primarily a drayage fleet. And a lot of that operation was shorter than 25 miles per hour. Very little was, in fact, above 100 miles. Still a decent fraction of the fleet was of the VMT was above 45 miles per hour, 42%. But this kind of represents the lower end of the VMT that was below 75 or 45 miles per hour. So the rest of the fleets kind of fall in between here. This is a flatbed fleet that was out of the Southern California area, kind of servicing the Riverside and Inland Empire area. And you can see it took some longer trips, but a lot of it was more regional and local. So here, almost 50% of the trips were shorter than 25 miles. Still here, we had 76% of the VMT above that kind of that 45 mile per hour mark that we're using. Okay, switching back up to Northern California. So this is a petroleum tanker fleet that we data logged that services Sacramento and sort of that the broader region in and around Sacramento. So this fleet again had kind of a lot shorter trips. About 40% of the trips were shorter than 44% were shorter than 25 miles, but we did still see a fairly decent size part of the VMT being above 45 miles per hour. Okay, container chassis fleet. This is a second container chassis fleet in the Northern California area. Again, you can kind of see from the trip origins that it did some work at the ports, and part of that was transporting those goods from the ports to, various destinations in Northern California and Sacramento and beyond. So a majority of the trips were less than 25 miles, and a quite big majority were actually even less than 5 miles here. But when you look at the VMT, again, if you're taking the very short trips, it accounts less for that VMT, so you still wind up with a fairly high fraction of the VMT being greater than 45 miles per hour. So this next fleet here is a refuse hauling fleet, and it had sort of a diversity of operations. It had some trips that were in the 25-mile range, as well as some trips that were longer, basically going from the Inland Empire down to San Diego. About 10% of the trips were those longer ones, and about 27% were in this shorter than 25 miles region. And again, here we were at 67% of the fleet greater than 45 miles per hour. Okay, another flatbed trip here, and another flatbed fleet here. This one is more of an agriculture fleet that came out of the Central Valley, and you can see that from the heat map they traveled to a wide distribution of locations within the state, and you can see that the mileage distribution was also fairly spread out as well. So we had a fraction of the fleets that were, about a quarter of the fleet of the operation was above 100 miles, about a quarter of the trips were below 25 miles, and then the rest was kind of in the middle there. Here we got about 84% of the VMT being greater than 45 miles per hour. And then we also did a tanker fleet in the Central Valley. And so again, this was more agriculture as opposed to petroleum products. Here we had 27% of the operation being less than 25 miles in terms of trips. And as a matter of fact, a lot of that operation was 0 to 5 miles per hour. And we had about half of the mileage was greater than 100 miles. And as you might expect, if you've got a lot of mileage that's a lot of trips that are more than 100 miles, you're going to get quite a bit of the VMT that's above the 45 mile per hour point. Okay, so this just kind of shows where those fleets might be in terms of looking at the potential benefits for aerodynamic devices. So on the left scale here is the annual mileage per fleet. Then the right scale represents the percent of the VMT speed that was greater than 45 miles per hour. So the ones that are in the upper right-hand corner tended to have a mixture of both higher speeds coupled with higher annual VMTs. Then we had some that we just kind of marked as moderate. Those had higher speeds, but not necessarily as high of VMT, annual VMT. And then on the lower side, we had the fleet that had the lowest average speed and also fairly low operation in terms of annual VMT. Okay, so in conclusion, we did a vehicle activity study, and we collected data from over 150 trailers that were equipped with our trailers of interest, either the container chassis flatbeds or tankers. It included 8 fleets, and if you look at the distribution, we had a pretty wide range of mileage, of annual mileages, anywhere from 20 to 80,000 miles. We had fractions of VMT that varied for greater than 45 miles per hour, varied anywhere from 40 to almost 95+%. But we did see that, even across all the variety of different applications we did see that most of the fleets had more than 66% of the VMT greater than 45 miles per hour. On average, it seems that there's possibilities for aerodynamic improvements for perhaps the broader range of fleets that we have there. There are certainly different things that we didn't investigate. We didn't look at the aerodynamics of the trailer themselves, tanker trucks versus a box truck or a flatbed that might have a lower profile relative to a container chassis. So that's some work that would be of interest. And, also in terms of, needing to have aerodynamic devices for these fleets, and looking at regulations, the possibility of, are there metrics that you can look at in terms of, annual VMT on a particular trailer versus the typical speed that the trailer goes by, and can you use that metric to, optimize your program and get a program that, is not overly burdensome, but has the aerodynamic benefits to the fleets that would most benefit from that. So just acknowledgements, funding from the research division, from the California Air Resources Board. We also worked in conjunction with the US EPA on this, and they provided the data logging, as well as we worked with them in terms of some of the data analysis, as well as ERG, or the Eastern Research Group. And of course, we want to thank all the fleets that participated. With that, I guess we will take questions.
Great, let's thank our speaker. Okay, so we'll take some questions in the room, and for those of you who are watching remotely, you can email questions. The email should be on the webinar page. So does anyone have questions in the room?
Hi, Tom. Nice talk. I'm just curious, do you have fuel economy estimates from this data collection?
We don't have, we haven't analyzed for the fuel economy. The information should be there in that most of the ECM, most of that data probably should include fuel use, or on a second-by-second basis. So we should be able to get that. Wasn't the focus of this particular project, so we haven't done that yet, though.
Hi, I have a similar question, basically focused on the idle trip. You said it's like the number of trips, like 25% above. And can you comment on that a little bit, the emissions versus the high-speed travel?
Okay, so it's possible. There's probably NOx sensor data in terms of the emissions that is there. We didn't, that wasn't, again, one of the focuses of this particular project, but I think both the fuel economy and the NOx information should be there for a decent fraction of these fleets, of the trucks. And so there hopefully will be information to answer your question with some deeper analysis.
So another question, just one more question. So you said there's a lot of like idle trip there. Have you considered the duration of the idling there? It's like over 5 minutes, less than 5 minutes, because that's kind of like the regulation require less than 5 minutes, right?
Yeah, I don't think we've looked at that yet. That might be something that we could look at. And in the report itself, when it's issued, which should be not another month or two, we do show distributions broken down for not just the non-idle trips like I showed in this presentation, but also for the full number of trips, including the idles. So
Thank you.
yeah. So, and we will be updating these slides, by the way. We're made a few changes, so those will be on the website probably within the next day or so, hopefully.
I'm Brandon Rose with CARB staff. One of my questions was the data logging devices completely transparent to the drivers when they were operating?
We tried to make those as transparent as possible, so we would generally try to bundle the cords and tie wrap them in a manner that, you know, where we pushed it as much and as far as we could below the dashboard. You know, it varied from driver to driver. You know, probably the small drivers like me may not have noticed them. You know, maybe some of the drivers did notice them, and, you know, all of a sudden, you know, the data logger would be here today, gone tomorrow. So we did, you know, so there was some fraction that did notice it, but generally the data loggers came back, and there weren't too many issues that we came about.
And then do you have, I know this study didn't cover this, but do you have any commentary on potentials for the aerodynamic devices on these different trailer types and the flatbeds and skirts and tankers?
Yeah. So we didn't go into, you know, a lot of the aerodynamic modeling in this particular study, but I do think that's certainly a next step, that now that this activity is understood, you can go and go to the GEM modeling, for example. There's a lot of capability there to do that. Again, wasn't part of what we were doing here in particular, but I think the information collected here, coupled with you know, different models, should be able to give a lot more information in that.
Okay, we have a few questions from online. So the first one comes from Jason Lewis, and Jason wants to know, what was the fueling mix of the tractors in the study?
The fueling mix, it was basically diesel fuel. All of these particular tractors were diesel fuel.
I have a second question from Mike Tunnell from trucking.org. So he says, Tom, interesting study and presentation. Nice work as always. Was the data from individual trailers or the tractor pulling trailers? If the latter, do you have data on how many different trailers were pulled by individual tractors during the study?
Okay, so the data itself, the data loggers themselves were pulled from the tractors as opposed to the trailers. So we did not data log the trailers. For one thing, we would have gotten a lot less information, and, you know, also the trailers, sometimes they're rented, you know, so it would have been very hard to get a captive amount of trailers there. So it was data logging on the truck itself as opposed to the trailer, but generally what we did was the trucks that we outfitted, either they were dedicated to a particular trailer in some cases. In another case, you know, for example, one of the drayage fleets, they operate entirely in the container chassis regime. So even though they switch those container chassis on a fairly regular basis, and actually each trip they switch them, the only product they're hauling, or the only trailers they're using, were container chassis. And then we did have one of the fleets where it was sort of neither of those, where they used a mix of different trailers, and there we had logs from the trailers that we were able to look at and investigate.
So I have another question from online. This is coming from, sorry if I messed this up, Kevork Hakatoglu from Ontario. Hi, thanks for the presentation. Which criteria air pollutants can be identified through the data loggers?
So with the data loggers, they should have a NOx sensor. So that's probably the most important segment of the operation. Probably not a lot in terms of, you know, you might get some indication of PM if you look at DPF criteria or something like that. But probably NOx is going to be the most critical part. And we may not have NOx information for all these particular vehicles either. It might depend. Some of these trucks are newer versus older, so it would just depend.
Any other questions from within the room? I don't see any more questions coming in from online. So with that, let's thank our speaker one more time. That concludes this seminar. Thank you so much for attending and for the people online watching and sending questions. Of course, you can follow up with Tom at a later date, and please keep your eye out for the final report and the updated slides, and follow up on those links that are provided in the intro slides as well. Thank you very much.